When you look at your feet or across a quiet landscape, the ground feels entirely solid. It seems like the Earth is completely still. Zooming into space to peek inside, Earth has extremely hot layers. The top layer, the crust, isn't a continuous shell. It's broken into giant puzzle pieces, tectonic plates. Floating on deeper layers, these plates move a few centimeters yearly, as fast as your fingernails grow. It might sound incredibly slow, but this constant, steady shifting of continent-sized rock is the exact process that builds the tallest structures on our planet. Let's look at this diagram to see what happens when two of these giant plates move straight toward each other. Because these plates are made of solid, heavy rock, they can't just pass through one another, so they crash together and push. Over time, the intense pressure gives the rock nowhere to go but up. The crust crumples and folds, much like what happens if you push the two edges of a thick blanket together on a bed. Because of how they are pushed and squeezed upward, we call these structures fold mountains. This aerial view shows the Himalayas. They are a massive chain of fold mountains. Because the plates are still pushing, they are still growing taller. The constant squeezing thrusts the rock layers all the way up into the sky, forming towering, snow-covered peaks like Mount Everest. So when you look at the highest peaks in the world, you are looking at the visible scars of a slow-motion collision happening right at the edge of our tectonic puzzle. But not every mountain is made by two plates crumpling evenly into each other. Sometimes one plate sinks instead. In this diagram, we see one plate sliding completely underneath another. As it gets pushed down into the hotter layers of the Earth, the solid rock melts and turns into thick liquid rock called magma, which rises up through the cracks. This photograph captures what happens when that rising magma breaks through the surface. It erupts as lava, spilling out before cooling into heavy, dark rock. With every eruption, a new layer of liquid rock cools and hardens. Slowly, layer by layer, the rock stacks up higher and higher. Because these structures are built entirely by escaping lava, they are known as volcanic mountains. If we look at this image of Mount Fuji, we can see a classic volcanic mountain. Its perfectly smooth cone shape comes directly from thousands of eruptions piling rock evenly around the center. While fold mountains squeeze existing rock upward, volcanic mountains use the Earth's internal heat to bring entirely new material to the surface. None of this happens quickly. Building a massive mountain requires millions and millions of years of steady movement. Many of the massive mountains we see today began pushing upward while dinosaurs were still walking the Earth. And the moment a mountain begins to rise, nature starts wearing it down. As we see in this diagram, elements like wind, rain, and ice act like giant sheets of sandpaper, scraping away the rock. This process is called erosion. We can actually see erosion at work in this landscape. Those soft, round hills in the foreground used to be towering, sharp peaks before millions of years of wind and rain smoothed them out. This split screen shows our two main mountain builders. Plates crashing together fold the crust upward to make fold mountains, while sinking plates push liquid rock up to form volcanic mountains. Mountains look permanent, but they are always rising and always wearing away. They are massive, living reminders of the incredible power moving right beneath our feet.